Okay, second practice problem here. At Disneyland, the 10 a.m. wait times of 4 popular rides are sampled. And so we see 4 popular Disneyland rides, Space Mountain, Small World, Indiana Jones, and Big Thunder Mountain Railroad. What they did, they sampled the wait time at 10 a.m. I don't know what time Disneyland opens. Is it like 9 a.m.? I would guess. I don't know. So by 10 a.m., right, things are starting to get busy. So we don't have all the details of the sample, but there you go. They sampled each ride 5 different times, but always at 10 a.m. to see what their wait times were. And we're going to investigate using 0.01 significance. Do the 4 rides have the same mean wait time? Well, I want to just kind of take a closer look here. Okay, Space Mountain, we have the 5 different times, 50 minutes, 25 minutes, 75 minutes, 35 minutes, 50 minutes. The average was 47, the sample mean, and the variance 357.5. Okay, there's quite a bit of variance going on. Small World, well, let's look at that data. 10-minute wait, 5-minute wait, 5-minute wait, 10-minute wait, 10-minute wait. Nothing compared to Space Mountain. Wow. Okay, Indiana Jones. Okay, now the times are getting up there again. 55 minutes, 50 minutes, 80 minutes. Okay, wow. And Big Thunder Mountain Railroad. I don't really hear people talking about that ride all that much, but I'm a particular fan. I like Big Thunder Mountain Railroad. A lot of fun. Right there in Frontierland, right in the middle of the park. 35 minutes, 40. Okay, wait times maybe a little bit lower than some of the others. All right, so kind of looking across the data, we see the mean for Space Mountain 47 minutes, the mean for Small World 8 minutes, the mean for Indiana Jones 55, and the mean for Big Thunder Mountain Railroad 42. So 47, 8, 55, and 42. Do any one of those seem different from the rest? Right? Small World, not nearly as popular of a ride, kind of back in the back of the park. Maybe people by 10 a.m. they're not necessarily sprinting back to get on Small World, before the crowd hits. So I think we can be suspicious. I think Small World might be different from these other ones. But we need to do the test, obviously, and we got a pretty low significance level, 0.01. So let's see what happens here. What's the null hypothesis? Well, we could do the sentence and simply write out the words that all population means are equal. That would work. Or we could use this style, mu1 equals mu2 equals mu3 equals mu4. We've got 4 categories here, so we need these 4 mu's. Space Mountain, right, Small World, Indiana Jones, Big Thunder Mountain Railroad. There you go. Either way works. How about the alternative? Well, the alternative hypothesis not going to change too much in your one-way ANOVA. The alternative is that at least one population mean is different from the others. So at least one of these is statistically different, can be shown. Okay, I've got my suspicions, but let's go ahead and go forward. So, calculating the test statistic F. Well, you're going to follow the same guidelines. I did not write them out again here on this page, but you're going to enter the data for each of those 4 rides into StatCrunch as 4 different columns. Again, don't include any of the X bar or S squared numbers, just the 5 wait times for each. Okay, once you do that, then you're going to go to Stat, go down to ANOVA, click One Way, and then highlight the 4 different column names and hit Compute. And you're going to get a whole bunch of information. But down toward the bottom right, you're going to see the F f equals 9.97 in this case, when you round to 2 decimal places. Now that's a big value of f. That's a big test statistic, very far from 1, right? Almost up to 10. And of course the p-value, very convenient, the p-value is right next to it and there in StatCrunch. This p-value 0.0006. And this just about wraps up our test. We compare the p-value to the significance level 0.01. And, well, that significance level quite a bit larger, and so we know to reject the null hypothesis. And if you wanted that interpretation, I included it as well. There is enough evidence that at least one mean wait time is different than the rest. When you do that interpretation, you do want that to be in the context of the problem. So at least one of these rides has a different mean wait time than the others. I wonder which one it could be. Now, what's kind of interesting, when you do a one-way ANOVA, so all it's saying, and all we have, the only information we have at the end is that at least one of them is different. We can't go that extra step and say, we know it's small world. Like, you're the one that's different and all the others are the same. I get, kind of the thinking behind that, but, how do we know that, Big Thunder Mountain Railroad might actually be different as well? All we're saying is that at least one mean wait time is different than the rest. It could be that multiple are different too. And so we could do more testing. We could just test Space Mountain, Indiana Jones, and Big Thunder. We could put those three together if we wanted and do the test again. Here, with the 4, though, all we're saying is, well, we know one is different. So they're not all the same, at least. Okay, that's it. That's our last practice problem. Check out the homework.